Hello, this is novaTopFlex. This will be a somewhat longer video, still under 10 minutes overall from the beginning of this video clip to the end. But in this video, I will be showcasing a random number, well, not a random number generator, but a pseudo-random number generator's output from the rand, R-A-N-D, function in C. This function is available in the this is not really a math function. This is a standard library, stdlib, stdlib.h. The libraries, the header files are not .c files, but .h files. So you do not necessarily need the math library for the random number generator, but you do need the standard library for this. Now, because the for loop has the POW function, POW, I need the math.h, sorry about that, anyway, because of it. And then stdio, that standard input output, I need that also because I'm using the printf command to perform this output. The random number generator, so I use the -uppercase N flag, so the line numbers on the very left are actually part of less, not part of the C program. And then the actual C program, column number 1, the first column, is %O, meaning octal. Column 2 is %x, meaning the alphabetical letters are lowercase hexadecimal. And then the third is %U. The difference between, I believe it's %lowercase d and %lowercase I. %lowercase d and %lowercase I are both for signed integers. %lowercase u, and only that, is for unsigned integers to be converted to decimals. So the same random number is the same random number for every row will be represented from left to right. Again, the line numbers are part of less, but the C program itself, and this is just C, this is not anything later like C++, it is octal, then hexadecimal, then decimal, and there is a limit. There is a limit. Specifically, we're looking at what I believe to be a 32-bit number limit. So up to 32 bits, but these are signed, so roughly 2 billion. I think it's roughly -2 billion to 2 billion. I think it might go up to 4 billion if it were to be unsigned. But the random numbers, I think that you can do positive or negative. I think the last bit is used for the sign, but all the rand commands, all the random numbers generated are positive anyway. So it's basically the same thing as saying they're unsigned. So 31 usable bits. The unsigned, the truly unsigned ones will have 32. These have 31 plus 1 equals 32 to make sure that you can do positives and you can also do negatives. I think the random number generator also allows you to do just that. Now, there is more information about these commands, and there can be some meanings to some of these numbers, but that's not necessarily how it works. Now, this is also, before I forget, not the actual output from the C command itself. I piped it to sort-n. That's why the numbers are sorted numerically. The actual output would not have any sort at all. The numbers, you wouldn't even know which number came first and which number came last unless you somehow knew the seed. But the seed is not. Now, if it were like this, you can't really say it's a random number generator if it's sorted like this, because it's going to be biased, but then the rand is already a pseudo-random number generator because you can never have a truly random number generator anyway. But again, so it's sort, meaning that I've sorted the contents, -lowercase n, meaning it's a numerical sort, and then I piped the numerically sorted output to less. Now, keep watching keep watching while the numbers approach and eventually hit just over 2 billion. At the very end of the video, you'll see numbers that high, roughly up to 2 to the 31st power. We are quickly approaching 2 to the 31st power. If you like this type of content or would like to learn more about C, C++, and other programming languages and whatnots, please like, share, comment, subscribe, and try to hack the YouTube algorithm. And thanks for watching. Signing off until next time.